Okay. So we usually write these solutions as an ordered pair in which the value of x is listed first and the value of y is listed second. So in this particular open sentence up here, I'd have the ordered pairs -1, 8, 0, 7, 1, 6, and so on. And they would correspond to the table that we filled in. All of these are solutions of x plus y equals 7. But it's not; those aren't the only solutions because there's an infinite number of solutions. You could put in any numbers you wanted. So those are just some. And they're true because when you substitute the ordered pair for the x value and the y value, you get a true statement. And I've been told by some of the other classes that I tend to talk a little fast. So if you catch me talking a little fast and I need to slow down, this is just the universal sign. So if you do this and I see that, then I'll know you want me to slow down a little bit, okay? But this stuff is pretty simple, so I think everyone's following along. All right. The set of all solutions is called the solution set. So if I had every single possible ordered pair, that would be the solution set of the open sentence. Finding the solution of the set is called solving the open sentence. Okay? So when directions say solve, that's what they're talking about. Okay. Solve each equation if the domain of x is -1, 0, and 2. So if I took the equation 2x plus 3y equals 7, and I substitute in -1 for my x, then I can solve that to find what y is. And so some of you can probably do that very quickly in your head. And what is y? Who can tell me what y is? Then it's just algebra 1, right? Y equals 3. Okay. And then over here, if I have 0, I would do the same thing. So what is my solution if it's 0? 2x plus 3y equals 7. So if I have 0 for x, what is y? Seven-thirds. Good job. And then I didn't realize that the starboard doesn't, for some reason when I write two down, it doesn't let me scroll down. But if I put 2 in there, 2 times 2 plus 3y equals 7. 4 plus 3y equals 7. And then 3y equals 3. Y equals 1. Okay? So if I solve this equation, what are the answers that I can get? 3, 7/3, and 1. Okay. So everyone has a paper. Do that for 4x minus 9y equals 5. So do that and throw in your 3 numbers for x, and then come up with 3 solutions for me. Take your time. Then when you're done, you can just look up and check your answer there. Everyone get y equals -1, 5/9. Sorry, negative 5/9 and 1/3. That's pretty simple, right? That's just algebra 1 substituting. Everyone understands that. We're all on the same page. Okay. Now we get these where it says complete each ordered pair to form a solution of the equation. So here we have some ordered pairs, and they give us one or two. They either give us the x value and want us to find the y, or they give us the y value and want us to find the x. So in order to do that, again, we're just going to substitute in. So if this is my equality, and I put in, if I know that for this one, if I know that the x is 1, then 1/2 times 1 minus 2y equals 1. And half of 1 is just 1/2 minus 2y equals 1. And then if I subtract a half, and then if I divide by -2, if I divide by -2, I multiply by the reciprocal of -2, which is multiply by negative 1/2. And that will give me negative 1/4. So go ahead and do the other two. So if you know x is 6, what's the y coordinate? And if you know if the y coordinate is 0, what is the x coordinate? Take your time. When you're finished, if you look up, you should check your answers, and you should have the y values. The coordinate's 6, 1, and the coordinate's 2, 0. Okay. Any questions on that? Okay. Find the value. Yeah. Negative 1/4? 1/2 times 1 minus 2y equals 1. 1/2 of 1 is 1/2. 1/2 minus 2y equals 1. Subtract a half. Negative 2y equals 1/2. Divide by -2. Oh, yeah, good. Yeah. So any questions on this? We're all good? All right. Next, the next section wants you to find the value of k in this equation. Find the value of k so that the ordered pair satisfies the equation. Well, if we know the x value and the y value because we're given the ordered pair, then it's just a question of substituting those in. So 3 times 2 minus k times -1 equals 4. And now you can solve that equation for k. So solve that for k and then tell me what you get for a k value. Everyone get k equals -2? Good. Okay. Solve each equation if each variable represents a whole number. Okay. Solve each equation if each variable represents a whole number. So you want to pick values here. I guess to answer that, when it tells you the whole number, the first thing you need to know, make sure we're all aware of, is what are the whole numbers. And so that's probably a review, but what is the set of whole numbers? Who can tell me? What's a whole number? It's all of the counting numbers, the numbers you counted with when you started in first grade. 1, 2, 3, 4, 5, plus 0. Okay? If you count just the counting numbers, 1, 2, 3, 4, all the way up, those are called natural numbers. If you take the natural numbers and add 0, you have the whole numbers. So it's 0, 1, 2, 3, etc. Those are all whole numbers. Okay? So that's all they're saying is find some whole numbers for the variables. So they don't want fractions, in other words. So find what whole numbers make this true. Well, if you plug in 0, you know that 0 times 4 is 0. So 0 plus what is 15? Well, it would be 15. And so that's all they want. Find all the whole numbers, which makes this true. So then you would go to the next one. 1 times 4 is 4. 4 plus what is 15? You can yell it out if you have it. 11. Does everyone see that? 4 times 1 is 4. 4 plus 11 is 15. And so forth. So 2. If we have 2, what would the answer be? 2 times 4 is 8. 8 plus what will give you 15? 7. And then the next whole number, 3. 3 times 4 is 12. What do we add to 12 to get 15? 3. And what about 4? If we put 4 in, what do we get? We're at 16. And so it would be 16 plus negative 1. Everyone follow that? Negative 1 is not a whole number, right? Because we said the whole numbers are just 0 on. So that won't be a solution. So the only solutions you can get where the variables are all whole numbers are these 4 set of ordered pairs. So our whole solution is 0, 15, 1, 11, 2, 7, and 3, 3. Okay? So there's only 4 possible solutions where both variables are whole numbers. Okay. Solve each open sentence if each variable represents a positive integer. Okay? So what do we mean again? We'll just review. So this is a positive integer. What's the set of integers mean? Who can tell me? What are the integers? Okay, so we'll review some of this number here. So if you take all of your whole numbers and add their additive inverses, you get the integers. Okay? So that means you still have all the whole numbers, 0, 1, 2, 3, and then their additive inverses, which just means that they're opposites. Okay? So negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. Those are all integers. Okay? All of the whole numbers plus their opposites are the integers. Okay, so solve the open sentence if each variable represents a positive integer. So they only want the set of positive integers. And so what did we call those before? What did I call those? What are positive integers called? Not whole numbers, because whole numbers include 0. We call them the natural numbers. You might have seen it like that with a capital N. The counting numbers, 1, 2, 3, 4. So that's what they want to know. So if the x and the y has to be a positive number, what solutions can we get? So the very lowest one we have is 1. So if x is 1, what is y to make that sentence true? Any number for y that will make that true. 1 plus what will be less than 5? Okay. So 1, 3 would be true. Okay. What else? 1, 2, because 3 is less than 5. What else? Well, they only want positive integers, so 0 we're not going to count. Okay. So what else? Let's see. X can be 2, so what could we put in there for if x is 2 that would give us less than 5? 2, well, that would make it true. What else? 1, that would make it right. And then if x is 3, what would y be? And is there anything else? That's it, right? Because if I put 4 in, there's no number I can add that would be less than 5. Okay? So my solution set would be those 6 sets of ordered pairs. 1, 3, 1, 2, 1, 1, 2, 2, 2, 1, and 3, 1. that's my solution set. Okay. The last section is a couple of word problems. I know these are all your favorite, right? These word problems. Okay. A bank teller needs to pay out $75. So the teller at the bank owes you 75 bucks. And she's going to pay you back, and she's going to use just $20 bills and $5 bills. And so the question says, find all the possibilities for the number of each type of bill the teller could use. So how would we set this up? Well, we know that you got $75 coming, so that's the beginning of the equation. So we know something's going to equal 75. So that's how much you're going to get back. And she's going to give you back $5 bills and $20 bills. Okay? We don't know how many $5 bills she's going to give you, so we can call that X. And you don't know how many $20 bills she's going to give you, so we'll call that Y. But notice these are different things. That's why we're using different variables. A $20 bill is not the same as a $5 bill. Okay? So you're going to get different numbers of both. But when we add them together, we're going to get $75. So this is really what the question is asking. He's saying, if I give you a certain number of $5 bills, and I give you a certain number of $20 bills, and I add them together, you need to have $75. So what are the possibilities? Okay, well, so how can she, what are all the different possibilities? She wants all the possibilities for the number of each type of bill the teller could give you back. Well, the simplest is, for $5 bills, what's the lowest amount she can give you $5 bills? 0, right. She could give you no $5 bills. 0 times 5 is just 0. So if she gave you 0, then what would Y be? 3? But if she gave you 3, that would be 60. You wouldn't have $75. Is there any combination that would give you, any number times 20 that would give you 75? No, because it would have to be a whole number. You could solve that like algebra. You could get a fraction, but you can't. The teller can't give you a fraction of a $20 bill. She's not going to take a $20 bill and cut off a part of it and give you part of it, right? So it's got to be a whole number. So that means that she has to give, there must be some amount of $5 bills that she's going to give you. So let's start with 1. If she gives you one $5 bill, you have $5. And she needs to give you $75 total. So that means she would have to give you 70 more. Is there any combination, any number of $20 bills that could give you $70? No. So you know that she doesn't give you one $5 bill. What's the next one? 2. Well, she could give you two $5 bills. That would give you $10. That would give you 65 left. Is there any combination that you could add 20s to get you $65? No. Okay. Where am I now? If she gave you 3 $5 bills, that would be $15. If I subtracted 15 from 75, that would give me 60. Now, is there any amount of $20 bills that could give me $60? Yeah. How many? 3. So, if she gave me 3 $5 bills and 3 $20 bills, then I'd have $75, right? Okay. That's all these things are asking you for, is find the combination, the possibilities. What if she gave you 4? Well, you know that this is always going to be an even number, and even multiples of 20. So the only time that this can work is if this is an odd number. Does everybody see that? You could try every single number and go through. But I know that I'm not going to try the even numbers, because an even number is going to give me an even number here, and when I subtract it, I'm going to have an odd number here. That's just something I noticed. So when you look at these problems, you want to sort of look at them intuitively. So what if she gives you a $5 bill? That's $25. If I subtract 25 from 75, that gives me 50. Is there any combination that'll work? No. What about 7? If she gives me 7, then I have $35. If I subtract $35 from 75, I have $40. Is there any combination there that'll work? What? 2. So she could give me 7 $5 bills and 2 $20 bills. Okay. And let's see. What about if she gives me 11? If she gives me 11 $5 bills, I'll have $55. If I subtract $55 from 75, I'll have 20 left. How many $20 bills would she give me? So 11 and 1. So that's your solution set. That's what they're asking for. What are the three combinations she can give you? She can give you any of those three combinations. She can give you 3 $5 and 3 20s. She can give you 7 5s and 2 20s, or 11 5s and 1 20. I'm sorry?
15 times 0.
Okay. 15 times 5 is 75 and 0 20s. Yes, very good. She could give you 15 5s and no 20s. Yeah. So you could get 4 answers. Gold star. 4 possibilities. All right. This last one is probably the most difficult. So we have to think about this for a minute, okay? A certain quadrilateral has 3 sides of equal length. All right. So it's a quadrilateral, and 3 sides are the same and one is different. So I try to think, like, what does this probably look like? So maybe it looks something like this. Something like that. It doesn't have to, but that's kind of how I picture it. Okay, so you want to draw a picture. Anytime you have anything with perimeter or area or geometry, it's always a good idea to draw a picture. It's a lot easier to understand. So a certain quadrilateral has 3 sides of equal length. So if they're equal, well, let's just use a variable to represent those, because those are all the same. Its perimeter is 19 centimeters. Find all the integral. So you'll see this word in this chapter and the next. This word integral, does anyone know what that means? The integral possibility means that the possibilities are going to be integers, even integers. So in other words, this is an even amount of, this side's either 1, 2, 3, 4, 5. It's not 1.5, 2.5, 1 1/3. These are integers. That's what that means when it says integral possibilities. Okay. Find all the integral possibilities for the lengths of the sides in centimeters. Okay. So this is a different length, so I'll call that y. So we know how to find perimeter, right? How do I find the perimeter? Anybody? Right, walk around the whole thing and add them all together. So x plus x plus x plus y equals 19. And then you can simplify that. 3x plus y equals 19. Well, if this side now is 1, well then that gives me 3, and what is y? If these sides are all 1 centimeter, so then all these are 3 centimeters, and the whole thing is 19, so how many is this? 16. So that's a possibility. So you could have, this says all the sides, so let's write them all down. So you could have 3, 3, 3, 16. Okay. Or if this is 2, that'd be 6. So what would this last side be? 13. If both sides are all 3, what do I have? 10. Both sides are all 4. What is it? 7. And if those sides are all 5, what's the last side? 4. What if they're all 6? It's 1. Okay. They can't be 7 because that would be 21. We'd already be more than what we need to be. And we know that again, you didn't need the hint, but it gave you a hint that the sum of all the lengths of these 3 sides has to be larger than this last one. That's the only way that it'll become a quadrilateral, because of the angles. So your answers are 3, 3, 3, 16, 2, 2, 2, 13. Did I? Oh, these were all 1s. I just rolled 3 times. So 1 and 1, 16, and so forth. So you have 1, 2, 3, 4, 5, 6 different possibilities. That's all this section is. They'll ask you different problems in different ways, but that's all the section is. Does anybody have any questions on this? Okay. You have about 8 minutes to start your homework. If you have questions, raise your hand. I'll come around.